everybody. We've got 2 o'clock p.m. Eastern, so we'll go ahead and get started today. Thanks so much for joining. My name is Christy Funk, and it is my privilege to welcome you all to today's Startup NASA Feature Series presentation. We really look forward to hearing from Linc Research and hope that you enjoy their talk. So before we get started, I'd like to point out that your microphones will be muted throughout the presentation. So if you have any questions, please type them into the chat box in the lower right corner of your screen, and we will take some time to answer those during the Q&A session at the end. So this monthly series provides an opportunity for NASA technology-derived startup companies to share their stories, including how they got involved with NASA and where they are currently in the development of their new product or service. NASA's Tech Transfer Program ensures that innovations developed for exploration and discovery are made broadly available to the public, and thereby we can maximize the benefit to the nation. And our T2X program augments that mission to include a focus on entrepreneurial innovation and creating partnerships to help accelerate commercialization. So this also includes a program called Tech Transfer University, or T2U, where we work in collaboration with academic institutions to provide hands-on real-world experiences for professors and students. So we invite you to visit the NASA Tech Transfer website for more information, to learn more about our available licensing opportunities and some of the initiatives that I just talked about. And please stay tuned for registration information for our next Startup NASA Feature Series presentation from Exhalence on August 18th. Thanks again for joining us today. We really hope you enjoy the presentation, and I'm going to turn it over to Michaela Waldner to introduce today's speakers. Michaela?
Thanks, Christy. Hi, everyone. My name is Michaela Waldner, and our featured company today is Linc Research Incorporated. Linc Research is an engineering services company specializing in structural engineering, technology transfer, optics, technology development and test, software engineering development and test, and a programmatic support area for NASA, DoD, and commercial missions. Linc Research is an SBA certified HubZone small business headquartered in Huntsville, Alabama. They have co-developed multiple inventions with NASA and are also current licensees of NASA-developed technology. I'd first like to introduce Linc Research's founder, president, and chairman, Curtis Taylor. Curtis holds a Bachelor of Science degree in Industrial Engineering from the University of Alabama and has conducted graduate work in Materials Engineering and Management of Technology. He has over 35 years of experience supporting NASA's human spaceflight and technology development, Army missile programs, and nuclear power. Prior to founding Linc Research, Curtis spent 27 years in managerial role with NASA, where he managed technologists and engineers for the in-space propulsion technology project and small satellite projects. Curtis has been awarded numerous NASA awards, along with Linc receiving multiple company awards. With Linc Research's impressive resume, I'd like to also introduce Chief Inventor Jeff Lindner. Jeff holds a Bachelor of Science degree in Mechanical Engineering and a Master of Science in Civil and Environmental Engineering from the University of Alabama, Huntsville. He began his career with NASA in 1985 and has over 31 years of experience in structural dynamics. Jeff is the principal inventor of multiple patents and was awarded Marshall Space Flight Center's Invention of the Year in 2017. It's my pleasure to be introducing our presenters today. Please enjoy the presentation. I'll now turn it over to Curtis and Jeff.
All around us, the destructive forces of vibration challenge design, erode infrastructure, and reduce the useful life of everything it touches. At Linc Research, we have developed a technology with our partners at NASA that fundamentally changes the vibration control environment. Introducing the revolutionary disruptive tuned mass technology. Originally used to address a complex vibrational problem hindering the Ares rocket program, disruptive tuned mass technology is applicable to a wide range of applications through simple, robust, and passive broadband tuning. The current state of the art is tuned to a specific frequency. However, during a high-energy or untuned event, the legacy tuned mass damper is no longer tuned and acts as an unwanted parasitic mass moving with the object, often with more destructive force than before. Disruptive tuned mass technology works differently. It is tuned to allow a broad band of frequencies that encompasses shifts and changes, such as under seismic loading or on rotary wing platforms, always moving at the optimal phase to disrupt the dynamics of the system. Our technology is proven through rigorous testing, baselined on the NASA Ares rocket, in use in other U.S. structures, in advanced development for launch structures and offshore platforms. The best part is the technology is scalable, from jitter damping of the most sensitive parts of satellites to remote locations at sea, and currently being developed where we find vibration in the most challenging environments possible. A natural fit in aerospace, we are already in development with the DoD and will be ready to apply our game-changing technology wherever vibration presents itself. We are Linc Research.
Thank you, Christy, for this opportunity and talking about how Linc Research and NASA are working together to solve problems. We're a little different than the companies you've heard up to date. We are working from within NASA. Part of our job is to be technical problem solvers. We're on a large engineering science contract under NASA, and commonly, and especially in the area of structures and mechanical engineering, we get called upon to look at unusual problems or new problems and help solve those. So this presentation is going to have, we'll give you a little more information on that. So let me share my screen. All right. So how did we get involved in the first place with NASA technology transfer? It really happened organically, as I said, as a result of our working with NASA to solve problems. One problem was on the Ares rocket program. This is the one that was around until about 2008, 2009, pre-SLS. The rocket was experiencing vibrations that were bad for the crew and the mission. So the resulting technology solution, authored by Jeff Lindner and the NASA program integration engineer, came up with an invention to use the weight of the liquid inside the rocket against itself to calm those vibrations. It ended up being baselined on the rocket, and in the aftermath of everything that was done for that program, discovered that we've had discovered a new way to handle vibration that has never been done before. So NASA provided some additional funds to explore possibilities for other applications. And as such, multiple patents have resulted along the line for vibration mitigation. The first technology area explored after Ares was mitigating building vibrations due to the wind they get, especially on the coastlines and in the deserts. The winds get high enough where they can move the buildings at the tip, plus or minus 1 feet. And if you're paying a lot of money for a penthouse in, say, New York City, then you don't want to be seasick. So there's always a damper of some kind on these tall buildings. And we designed one using our technology for a structural engineer who ended up being the one to hold the first license for this technology. We ended up building, Linc ended up building the actual dampers for the company to be installed on the building, and it's successfully functioning and still functioning now. And that licensee actually eventually spun off a new company. Bottom line is we hold many co-patents with NASA, joint ownership agreements, and we have one commercial license with NASA for the disruptive tuned mass damper. Let's see. So what we were looking for did we have technology looking for a problem, or did we have a problem looking for technology? So in the process of solving the problem, NASA and Linc created this unique and novel technology and found as patentable. Goes along with the old line you've heard, necessity is the mother of invention. Problems we have solved or are solving now are, can we mitigate dynamics on the NASA Ares rocket? Could we mitigate excessive deflections in a multi-story building during high wind? Can we redesign a helicopter vibration damper? Can we stabilize the new NASA SLS rocket due to wind on the launch pad? Can we stabilize offshore platforms for oil rigs, large wind turbines, et cetera? And there are other novel questions and methods we're looking at right now for future aircraft design, fuel tankers, future battlefield scenarios, and even in hypersonics. While we solved this problem, what we found out also when we started solving the problem with the rocket, we saw that everything we worked on was applicable to every other problem that was coming down the line. So, you know, creating a whole new technology and a whole new way of thinking. For example, the technology for a building or a rocket can also be used for any tall or long, slender structures. So how do we advance the technology? I'm going to show you a process on the next page for advancing the technology within NASA. But also in addition to that, you have to have for a small business, you have to have a great large business to work with. And we've been working under Jacobs for many years doing this work, and they've allowed us to grow this kind of work throughout the years, and they're there to help us. So next page is it's not bad for a government organizational chart, if you will. But on the left-hand side, you can see where civil servants or contractors start a process for a new technology. And then NASA legal gets into it and says, is it patentable? And then the tech transfer office says, does it have commercial potential? And if the commercial potential and the patentable questions are yes, then it's filed. The patent does get filed to the USPTO. T2, tech transfer, markets the invention. And then a company has the option to license the invention, and when sold, pays back to NASA royalty. And on the side, the inventor also receives a percent of the royalty from NASA. At the bottom, you see a process for software. We don't get involved in software, and software is a whole different process. So maybe if that's a topic you want to talk about in the future, maybe you contact the tech transfer office. So I started this company back in 2014 after many years working with NASA, and been through all the headaches and happiness associated with being an entrepreneur. But so I was asked, what are some of the needs of entrepreneurs? Well, you have to have passion. Entrepreneurship cannot be about getting rich. You know, it's the big life questions. Why do you exist, and what do you want to do in your life? Has to tie in with you starting a company. And you have to have a high tolerance for risk. Many risks associated with being an entrepreneur. You know, on the money side, lose your investment, go without a salary. There is a thing called IP theft, and partnering with the wrong people, or even should you partner at all. Thirdly, the right use of money, balancing cost of people, internal research and development facilities, where you take a profit, reinvest profits. And of course, this is all after you have met payroll. And again, profit can't be the only goal. You have to grow a talent pipeline from early on. That's critical to growing your capability, is having this talent pipeline ahead of need. You have to have flexible facilities or infrastructure to do the work that you need to do especially when you're running ahead of the customer. And this last one I can't explain, it's not quantitative, but the ability to see around corners. You know, some are better than others. You can think of a few, I'm sure. You can enhance the skill with experience, but you do need the leadership of the company to have both a right and left brain. And then further, as you go, what kind of needs does the entrepreneur have working with the federal government? Patience is a good one. These aren't listed in order, but patience, common way this works is a hurry, and then wait, and then if you win it, go. You know, however, there is a big push among all agencies to acquire, especially innovative technology faster, you know, but in reality, there are a lot of variables in that process. You may can work it out where it's to your advantage, but maybe more than a month before you get your first paycheck and you've already paid 2 paychecks. So you have to have that ability to flex up front with a good bank, especially. It's this is probably maybe the most important thing, is to be a team player. You need to be known as a team player, working directly with the government, for the government, alongside the government, and under a large prime contractor. Experience in the system is good, is needed. Within each agency, there's a lot of ways to perform acquisition practices. Knowing the points of entry is key, because you could talk to an engineer with a program all day long, but they don't make the money go, and they don't start the contracts. So the best place to start with working, especially with NASA, is start with the small business office. Each center has their own small business office, and then headquarters has the associate administrator for small business. Come in with the knowledge of the programs. You don't want to be learning about it when you first start talking with the government. But somewhere along the line, you also have to understand that other than having great R&D effort, you have to learn how to insert your technology into a program, how that process goes, what the program manager what kind of risk will he accept. So there's a lot of pieces to getting your R&D inserted into a technology or into a program. Having said all this, I've worked with NASA since '84 when I'm out of college, and they are easily one of the top customer support and some of the most inspiring work I've known. I started out in the shuttle program around STS-6, and as I said, a lot of fun, especially for a young engineer. What is our strategic path? We're going to continue to innovate and solve problems. As a matter of fact, that's half of our mission for Linc Research, is solving problems. And we can do that through service contracts or innovation and technology. Like, for example, we also have, we won a SBIR under the United States Air Force innovation lab called AFWorks, and we won the position on an exercise with Special Operations Command. In the future, I'm right now sitting in our new prototyping lab. We're going to create a dedicated, fully staffed lab so we can move at the speed of relevance. If you've been in innovation and technology in the government, you've heard those words. Build some manufacturer capability. We don't plan on being a heavy manufacturer, but we certainly can do light manufacturing, one-offs, first articles, things like that. Continue to participate in the federal and industry innovation labs. Be where the problems are being first noticed. And lastly, as a hub zone company, we've been working in inner city areas, and we want to create an innovation mill in this area to tap potential of communities not typically part of the innovation and ideation cycle. Just as a background, our program experience actually spans back to Apollo days. But we worked on a number of problems. We're working with KSC now. We also work with JSC, and then a number of programs at Marshall, from Space Lab to SLS to Space Station, and all the work going on around technology development and the SLS. Finally, I'll get off the chart with some, instead of talking about it, I'll show you pictures. Top left is the recent innovation that is being continually developed. Is for the right now. It's in a building at Marshall, attached to the building for the sake of testing its capability under vibration. And this eventually will go on the new KSC Mobile Launcher 2. Bottom left is an early prototype looking at how to create a new ballast systems for offshore platforms. In the middle, you see a helicopter vibration damper that we've added some some dampening mechanisms too, and we're testing it on a shaker to characterize its performance. Top right, we're working on the large damper that went on top of a building in Brooklyn, New York. And the bottom right is another example of a different kind of system to work to manage the ballast of an offshore platform. And I believe that is it.